Hey everyone, I'm super excited to bring you my latest lecture today on building an AI chatbot with the Vercel AI SDK. Now, in this lecture, we're going to build a chatbot from the ground up using Vercel AI SDK in a NestJS backend and a Next.js UI. We're going to see how we can implement its streaming functionality to stream responses back from this chatbot, parse that stream easily using client-side hooks. So for example, if we have a message here, the message text will appear immediately as soon as we receive data on this stream instead of waiting for the full response, which is a great pattern in chatbot applications. We're also going to connect this to the Vercel AI Gateway, where we can have a single point, a single API key, and get access to all of the top leading AI models. And I'll even show you how we can then swap out our models at any point in time in the chatbot without having to change our code at all, thanks to the Vercel AI SDK. Finally, we're going to look at how we can use the tools in the AI SDK, which will allow us to actually feed it data from our own application and let the AI model actually call functions that we define, making it super powerful. So in this app, we'll implement a weather-based tool that we can invoke dynamically based off of user input and generate weather data. We're also going to see how we can build a generative UI and build a UI out of that tool response like this weather card here. So I'm super excited to jump in. By the end of this lecture, you're going to be able to build your own AI chatbots using the Vercel AI SDK, see how easy it is to add AI chat into your application and bring a lot of value to your users. So let's go ahead and jump right in. Real quick before jumping in, I want to let you know you can get access to the full, almost 3-hour version of this lecture where we take this example even further and add message persistence with our NestJS backend and hook it up to a Postgres database with Drizzle ORM so that we can actually persist our chats after we've completed them. So here we can load our chat history from the database, and I'll show you how we can serialize and deserialize these messages and chat data with ease using the Vercel AI SDK and Drizzle ORM. So again, if you want to get access to that, I'll leave a link below where you can check out my developer website and get access to this full, almost 3-hour lecture and get access to all my best-selling Udemy courses and exclusive developer content. First step in this project is to make sure that we actually have an account with Vercel. So if you don't already have one, head over to vercel.com and click on the sign up button. It's going to be completely free to sign up for a new account. And then Vercel AI Gateway will actually give us $5 of free AI credit to use in their AI Gateway, which will be plenty of credit to follow along with this project. Now, the Vercel AI Gateway is a platform that actually aggregates together all of the cloud-based LLMs or AI providers into one single platform. And so this is going to give us the ability to actually choose whichever model that we want inside of our chatbot application. And we'll actually be able to switch out the model in real time inside of our chatbot in this project. So we can switch around between different models and providers like from Anthropic, Google, and OpenAI. And this is great because depending on the use case of your application, you might want to choose a different model as they all differ in terms of their processing power and cost. And we can see this all listed out here on their models page and even see the highest ranking models as of today. And so this AI Gateway is going to give us the ability to interface with all of these models in a single spot. And that's the benefit of using Vercel AI Gateway, is that we have all these models and we only have to manage one API key in order to get access to all of these AI providers. And the best part about this is that thanks to the Vercel AI SDK, our code is going to be agnostic of the provider we're using, so we can easily swap out a provider without changing any of our code. So again, make sure you go to vercel.com and sign up for a free account and then log into your account. So once you've gone ahead and created an account, you'll want to go ahead and click on the AI Gateway tab once you've clicked into a new project and a team. And then we should see this AI Gateway tab. So if we click here, you should see about $5 in free credit for your account. I've added some additional credit here. But again, the $5 credit we have for this project will be plenty. So within the AI Gateway tab, we can click on Model List to view all of the models and get the name for them so that we can hook into them. And then importantly, we see an API Keys tab. So this will be useful later on when we set up our backend, and we'll need to provide it with an API key to actually authenticate with our Vercel AI Gateway. And that's how we're going to get access to all of the models listed in the model list. So keep this tab open so that we can create an API key once we have our project up and running. All right, so now we're ready to initialize our project. So for this project, I'm going to use Turbo Repo as our monorepo manager because we're going to have a monorepo with both our Nest.js backend and Next.js UI in the same repository, which is going to make things a lot simpler. And I just like the organization of using Turbo Repo. However, you could separate these out into however you'd like. So for Turbo Repo, we're going to initialize a new project using pnpm. I'm going to use pnpm as my package manager as well, and we'll run dlx create turbo at latest. And so it'll ask us where to initialize the project. I'll go ahead and initialize it into a new folder I'll call Vercel AI SDK NestJS Next.js. You can call it whatever you'd like. And then I'll use my pnpm package manager. So go ahead and let the project initialize. And with the project initialized, we should be able to now cd into our directory. And let's go ahead and open it up in our code editor. So now in our code editor, we can see the starting structure for our Turbo repo, where we have two default generated Next.js UIs in the apps directory and some default packages in the packages folder. Now, this isn't a deep dive on Turbo Repo. If you'd like to learn more about it and this architecture, I'll leave a link to a previous video that I've done on Turbo Repo. Let's go ahead and finish setting up this Turbo Repo for our project. Now, in our project, we'll have a single Next.js UI that will render the chatbot out. So we'll keep the web directory, which is a Next.js app, using the app router approach, which is exactly what we want, which is the latest and greatest. So let's remove this other docs application, which we won't use. And then I'll go ahead and clean up this web folder a bit. So in the app directory, we have a page.tsx at the root. And thanks to the app router, we know that this will correspond to the root path of our application. And so this will be the home page. And that's where we're exporting here a component called home. Now, by default, this is some boilerplate Turbo Repo JSX. Let's go ahead and start off with a clean slate. So I'll remove everything from this homepage component, and let's just re-export it as function home and return a completely empty JSX for now. We will build our chatbot UI inside of this home component later. And then we can remove the CSS file that's associated with it. We have our layout.tsx, which is the default layout file, which we know renders out the HTML and body tags since it's at the root of the app directory. And this also renders out all of the other children in the component hierarchy. So we can leave this as is. In global CSS, we have some starting styles that I'll just remove since we don't need these. And now the Next.js UI should be all set and ready for our changes. Next up, let's go ahead and generate the Nest.js backend as well inside of the apps folder. So back in the terminal, let's cd into apps, and we're going to use the Nest.js CLI to create a new project in here. If you don't have it already, you can use npm to install it globally, just using @nestjs/CLI at latest. Once you have it, then we can run nest new to initialize a new project, and we'll call this the backend and use pnpm. So this will create a new Nest.js backend inside of our Turbo Repo apps folder. And so now that the Nest app is generated, let's make sure that we cd into backend and run remove on the Git folder in this folder, because by default, Nest will create a Git directory, but we don't want this because we already have one at the root of our Turbo repo. So we'll go ahead and remove this. And so now back in VS Code, we can see in apps, we have the backend directory, which is our starting NestJS application. We can see we have our starting app files. So we have the main.ts, which creates our Nest application and then bootstraps the HTTP server by listening on the port environment variable, or it will use port 3000 by default. Now we want to make sure we change this value to 3001 because 3000 is where our Next.js server is listening, and so we don't want to conflict with that. So let's change the default port so that our HTTP server will be available. And so these starting Nest files, we have the app controller and an app service, which by default are just exposing a single get route. So we can see our app controller exposing one get route. It injects the app service, and that's returning a stub hello world string. So we can keep this for now just to test the server starts up okay. One other change we need to make is in the package JSON for the Nest app. Since we're using Turbo Repo, when we run our commands, it'll execute it for every application in our apps folder, thanks to Turbo Repo and our npm workspace configuration. So for our NestJS backend, we can check to see that we don't have a dev command. Instead, it's start dev. So we want to rename this to dev so that it aligns with the same dev command that our Next.js server will use so that we can start both of them with a single command. And all this does is start up the NestJS development server so that we recompile with any changes and start the app. So with this change in place, we should be able to start both applications with our turbo dev command and be ready to start developing the AI chatbot. Let's go ahead and test it by heading back to the terminal. We can go to the root and we'll run the turbo dev command. Now, if you don't have Turbo Repo, you can use, again, npm install turbo at global, just like we did for the NestJS CLI, if you need to install it globally. Otherwise, if you already have it, if we can run the turbo dev command, which will run the dev task in the package JSON for each application inside of our Turbo Repo, so that will start up our NestJS server and the Next.js UI. So the Next.js UI will start at localhost 3000, and the backend, since we changed the port, will expose our HTTP server on 3001 and map that single get route we defined. So with both of these servers running, let's head back to the browser. In the browser, if I navigate to localhost 3000, where the Next.js server is listening, we can see just an empty white screen, which is exactly what we want because we cleaned out our home component. And so now we have an empty slate to start from. In another tab, I went to localhost 3001, where the Nest server is listening, and we can see the stub hello world string returned, which is where our get route is listening for traffic. So this is great. It means both of our apps are running successfully, and now we can start adding in our Vercel AI SDK integration. Let's go ahead and start with this next. All right, so to start off, let's go inside of our backend directory and start creating our chat functionality. To start, I'm going to go ahead and remove the starting app controller files since we're not going to use this in our project, and we can just clean this up. So let's delete those files and then make sure we go back into the app module and remove the references. So we're starting off with a blank slate here. And then we want to create a new directory where we can host all of this chat related functionality inside of our source folder. To do this, we can make use of the NestJS CLI, which will automatically create new modules, controllers, and services for us and wire everything together. So we just need to cd into apps backend, and we'll use the Nest CLI to generate a module firstly called the chat module. This will create a new chat directory with the chat module and then import it inside of our existing app module. We'll also go ahead and run it for the controller type so we can create an HTTP controller that will update the chat module as well. And then finally, I'll generate a service as well for chat. where we'll keep all of our business logic. So now if we head back into the backend, we can see we have the new chat directory with our chat controller and our chat service. So this chat controller is prefixed with chat, and it has no routes to begin. The chat service is just an empty injectable. And then finally in the chat module, we're declaring the chat controller in our controllers array and the chat service in the providers array, which means we can inject it into other classes at runtime. And lastly, as I said, this is imported into the root app module so that our Nest app knows about it. And so this is good. We can now start creating the chat functionality. I'll go ahead and remove the spec files that we're not going to use in this app. And so our first step is going to be to define the HTTP endpoints that our chat app is going to use. And so for this, we're only going to need a single post route that we can send our chat conversation to that will be then fed into the LLM model that we choose, which is then going to process the conversation and respond back with a message from our AI provider. So let's go ahead and define a new @post route inside of the chat controller, and we'll call this method chat. So we'll leave this empty for now until we implement the chat functionality. Let's also go ahead and inject the chat service that we've set up, which is where we're going to actually keep the business logic associated with creating the conversation and sending it to our LLM. Now, before we can start filling out our chat controller and chat service, we need to go ahead and install the actual Vercel AI SDK that's going to take care of receiving our chat messages and process these back to the client through a stream, which we'll dive into in a little bit. So let's go ahead and make sure we have the dependencies we need. So in our terminal, make sure we're in the backend directory. All we have to do is npm add the AI package. And so now that we have the AI dependency, we can go back to our root and restart our development servers. And so now that we have the AI dependency, let's go back to the chat controller and finish filling this out. So in the chat controller, we're going to extract two parameter decorators. The first is the underlying body, the HTTP request body, which in our case is going to contain the actual messages associated with the given conversation. So we can define this type as a literal type here where we have the messages property. And so for this type, we actually have a predefined type that the AI package defines for us. This is going to be of type UI message array, which is a predefined format for sending model messages using the Vercel AI SDK. And so when we use the Vercel AI SDK, it's going to take care of preparing these messages inside of this UI message format that the server expects to be able to process. And so that's why we can reference this nicely generated type from AI dependency. So we have all of the messages that have been sent in the given conversation. We will also take in another property, which is the model itself, which is optional type of string, so that we can actually change the underlying LLM model that we are sending our chat messages to at any given time. Thanks to the Vercel AI SDK, we're not going to have to change our code at all. Instead, we're simply going to pass the model we want as a string to the gateway, which is a great benefit of using it. And so now that we have the HTTP request body, the second parameter we need is actually the underlying HTTP response that our Express server has created for the given request. And the reason we're doing this is because the Vercel AI SDK actually allows us to stream a response back to the client. Instead of preparing the response in its entirety in the backend, building it up, and then sending it to the client in a single go, we can instead stream the data from the model back to the client in real time as we're receiving it. And so just like if you use ChatGPT or another chatbot before, when you send a message to it, it will start streaming the text on the screen instead of waiting for the final response. And that's exactly what we can do here. We can take advantage of the streaming functionality from the AI SDK and give our users a really fast experience working and chatting with these models thanks to the streaming functionality. And so in order to pass a stream back to the client, we need to get access to the underlying HTTP response object that our underlying Express server is opening up for us. In NestJS, we can do this with ease using the @response decorator, which will pull off the underlying response object from the current request. And so we can import the response type from Express. And so now we have both of these parameter decorators that we need. We're going to go ahead and simply call this .chat service and call .chat on it, pass in our body.messages, body.model, and finally the response object itself so that we can stream back the response to the client. Now, if you get a type error around the response type, simply go into your TS config for the Nest backend and make sure we set isolated modules property to false, which should then take care of this type. And so now at this point, our controller is actually complete for our chatbot functionality. The last thing we need to do is go into the chat service and actually use the AI SDK to pass in the messages from the HTTP request, our chosen model, and finally stream the response back to the client. So let's go ahead and do this next. All right, so actually implementing our chat functionality with the Vercel AI SDK is going to be very straightforward to do. We're just going to head back into the chat service and let's now create our chat method that gets passed in our array of UI messages that are going to be coming in from our UI client-side library that we're going to use later on. And so these are going to be the messages that were exchanged by the system itself and by the user. In the same conversation, we'll have an array of UI messages that represent the conversation. We'll have the model that we're going to send the request to, which I'll make as undefined potentially. And then finally, we have the raw Express response objects. We'll import response from Express. And now what we're going to do is firstly convert our UI messages into a model message, which is the format that our AI SDK methods will expect the messages to be passed into. So we have the UI message format and then the model message format that we're actually passing to the model. So let's create these model messages. And so we'll use the model message array type. So we'll set this to an array and spread the function called convert to model messages. And so this is a function from AI that allows us to pass in UI messages, and it will automatically translate and convert them into the model message format that we're expected to pass into the model. And so this makes it very convenient to format the message that we need. Next up, we're going to actually create the result of passing the model messages into the model that we're choosing and stream this back to the client. To do this, we can use the function that AI exposes called stream text. And so stream text is going to take in a number of options inside of an object that we can essentially pass to the model as configuration. The first, of course, is going to be the model itself that we're going to be using. Now, as we saw earlier, we can see an entire list of all of the models available to us inside of the Vercel AI Gateway. If we head back to our Vercel dashboard and click on the model list, so the name here in the model catalog is what we're expected to then pass into the model string to choose which model we want to use. Now in our case, like I said, we're going to be passing this from the UI itself so that we can dynamically change this at any time. So let's go ahead and make the model actually a required field. We'll change it in our DTO. And then in chat service, we'll say the model is always defined and then just set it on stream text. So now we're choosing the model using the Vercel AI Gateway. The next required property is simply the messages that we're passing to the model. So in this case, we can now use our model messages, which are the converted UI messages in the format that this model needs to actually read in our messages, process them, and stream the result back. So now that we have this stream that's been opened up by the AI SDK that will pipe back data once it gets back from the model provider, We now want to pipe this along to the actual response object so that the client can start receiving data as soon as the stream opens and starts actually pushing data onto it, in our case, a response to our latest conversation message. To do this, we can pull this off of a variable called result, and on the stream text result, we can see a number of parameters that allow us to manipulate the stream, get more information about it. In our case, we want to use these helper methods called pipe UI message stream to response. And essentially, this is a helper function which will allow us to use a matching UI client-side library to read from this response built because it knows the exact format thanks to this pipe UI message stream response function. So this is going to make reading the response on the client side very simple to do. And all we have to do now is simply pass in the express response object, and the AI SDK will take care of writing to it. Now we're calling stream text, passing it the selected model, as well as all the up-to-date messages. So when a user is sending a new message to this endpoint, it will be the last entry in this model messages array, and the model will know to prepare a response to the latest message, and it will also have for context all the previous messages in the conversation. And that's really important, is we're passing this context along with the conversation to the model, as well as the latest message, which it will be conjuring a response to. Now we could take this much further and introduce a system prompt, for example, which essentially is just going to be a message that we always add to the beginning of this messages array, and would be a set of instructions that we want to provide to the AI model in case we want to make it more directed or have some sort of personality or style the messages in a certain way. Really, the possibilities are endless. We can do that by prompting the stream text function with this system prompt at the very beginning. In our case, we'll just leave it open-ended so the user can really have full range to interact with the LLM directly. And this is essentially all we need to get up and running with the Vercel AI SDK Gateway in a chatbot, just this small function, thanks to these helper methods. And it means our UI is ready to actually get set up and connect to this backend, start posting messages to our chat post route, and seeing the AI SDK in action. So let's go ahead and continue doing this next. Finally, this stream text function is communicating with the Vercel AI Gateway with the model of our choice by default. So for this to happen, we need to be able to authenticate with the Vercel AI Gateway with an API key, which we saw earlier inside of the Vercel UI. And so we want to be able to provide this API key as an environment variable to our backend. So let's go ahead and do this by adding the NestJS config dependency, which is going to just use the .env library underneath the hood to read in environment variables. So go ahead and install at nestjs/config. And then we can go inside of the root app module for our application and import the config module from nestjs/config and call for root on it. Pass in is global to true to make the config service globally available. And so now at this point, environment variables will be read in from a .env file if we create one at the root of the app. So let's do just that by creating a .env file in our backend root. Now we need to provide our Vercel AI API key. Now the AI SDK that we're using by default will automatically look for an environment variable called AI Gateway API key to authenticate with the Vercel AI Gateway. So we just need to provide this environment variable, and our authentication should happen automatically. So to do this, make sure you head back into the Vercel UI, log into your account, click on the AI Gateway tab, and then click on API keys. Once in API key, you can click on Create an API key and copy the key that it provides you. This will allow us to access any of the models within the AI Gateway. So I've gone ahead and copied that API key and pasted it into my .env. And so now our application will read it on startup, and our stream text function should successfully be able to authenticate with the Vercel AI Gateway. Okay, so to set up our UI for our AI chatbot integration, we'll first start off by installing the dependencies we'll need. cd into apps web directory, and we'll run npm add to install our new dependencies at AI, which is going to be the same AI library we've been using in the backend. And this will allow us to use a ready-to-use transport configuration to stream back our messages from the server and send new messages in the UI message format that the backend expects. We'll also go ahead and add the @AI SDK/React dependency. And this is going to give us access to a special React hook called useChat that's going to allow us to configure our text stream to the backend. Now, in addition to these dependencies, I also want to set up Tailwind in our project so we can add some basic styling to our chat, make it look nice. So we'll go ahead and npm add as well, Tailwind CSS, at Tailwind CSS/post CSS and post CSS. And before we start the server, let's go ahead and configure Tailwind. So to do this, we'll open up our web directory and make sure we create a postcss.config.mjs file where we need to go ahead and create a basic configuration object where we define a plugins property, which is an object that will add the Tailwind CSS/post CSS property to and set it to an empty object, and then go ahead and export this post CSS config object. Finally, we'll go into our app globals.css file and add a single import now to Tailwind CSS. And this will allow us to now use Tailwind inside of our project to make our styling a lot easier. So we can go ahead and now restart the development server for the UI and backend. Also go ahead and re-navigate back to the application at localhost 3000. And let's go ahead and now add our chat component to start building the chatbot out. All right, so the first thing I want to do is head into our root layout.tsx file, and let's add some default Tailwind classes to our body because I want to make the app dark mode. It's kind of hurting my eyes to look at this white app at the moment. So let's add the background gray 950 class and text white. So this will apply a Tailwind background based on our current selected theme of background gray 950 and make all of our text white. And this is what we want. So now we should see this nice bluer background, and our text will be inherited with this white color, which is what we want against this blue background. And so now we have some dark mode styling for our app. Let's head into our page.tsx, the home page, where we're actually now going to set up our use chat hook to connect to our chat endpoint so that we can send and stream messages to our selected model and build out the rest of our chat components. All right, so next up, let's head back inside of our homepage component. And the first thing we're going to do is keep track of some state inside of this component. So the first state I'll have is the selected model because, as we know, we're going to be able to choose between our different model providers in this chatbot. So we'll keep track of the selected model and have the set selected model function destructure it from an array and then call use state. And so here we can go ahead and provide the default model that we want our chatbot to use. So feel free to copy any model available on the Vercel AI Gateway model page. For this chatbot, we can use the Google/Gemini 2.5 Flash Lite model, which is a very affordable and fast model. That would be a good choice for our chatbot. But you can change this to whatever model you want the default to be. Next up, we're going to go ahead and set up our use chat hook, which is the actual client-side library from our Vercel AI SDK that's going to set up our connection to our backend and be able to send and read data on the stream that we open up. So this is going to be a hook, and we'll go ahead and destructure 3 properties on the return object of the hook. This is going to be the messages array, which is going to be the current array of messages from the current open stream. We also have a send message function we can use to push more messages onto the stream, essentially invoking our chat post route that we've set up earlier. And then finally, we have the status property we can pull off to get the current state of the model stream. So let's set this equal to the use chat hook from AI SDK/React. And so now this takes in an options object where we have to provide a property called transport, which is going to define the transport layer we're going to use to connect to the backend. Now AI comes with a default chat transport class that we import directly from AI that will allow us to consume a stream that is built using the corresponding AI backend library where we create a UI message stream just as we did before. And so this is how we're going to consume that with this default chat transport. Here we have to specify the API property, which is where the chat endpoint is actually hosted at. So in our case, for our NestJS backend, we know this would be at localhost 3001. And at our /chat endpoint, because we know our chat controller that we created, we're prefixing with the chat text. So that's where we can find our chat post route, where we want to send our chat request to and open this stream up. Now, by default, this won't work by sending HTTP requests to a cross origin because we will receive CORS errors in the browser trying to do this. Instead, we can proxy this request off using our Next.js server. So let's go ahead and set the base path to at /API, and then we'll forward any request at /API to the Nest.js server and include our /chat endpoint. We can then specify additional properties that we want to be passed along to the body of the outgoing request. By default, this chat transport will include a body with the messages property, which will include all of the messages in the current conversation that useChat is managing the state of. And so that will correspond to our post route where we defined the messages property as the UI message array. And so that's exactly what will be populated, is these array of UI chat messages. However, we know we also want to pass the model along in that request. Now, useChat makes this very easy to do. We can pass the body parameter to pass along extra properties that the endpoint will receive. And so in this case, that's going to be the model property we want, set equal to the selected model in this component. So now the post chat route will receive all of the UI messages in the conversation, as well as our selected model, and so that's great. The last bit of state will be the actual current input text that we're capturing from the user in the chat box when they're typing a new message. So let's keep this as input and set it to an empty string by default. So now we've set up our component to have all the state it needs, and we've set up our use chat hook with our chat transport to successfully open up a stream to our chat route that we created. We need to go ahead and make sure we configure our next config.js at the root to have this path rewrite to proxy our requests off to. To do this in the next config object, make sure we define an async rewrites function that will return an array of rewrites. So we'll have a single object. We'll specify the source as /API /path star. And so this will capture any traffic received on the Next server at this API endpoint, and anything past it will capture in the path variable. And then we can rewrite it to the following destination, which will be our Nest.js server. So I'll pull this off of an environment variable called API URL, and we'll pass along the original path of the request. So that will remove the /API, send the request to our Nest server with the original path we wanted. So in our case, that would be at /chat, which corresponds to our chat endpoint. And this is happening on the Next server side, so we'll avoid any CORS errors thanks to this rewrite. Just make sure in our Next.js web directory, we also create a .m file. And so Next.js will read in this file by default. We just want to set API URL now to HTTP localhost 3001, where the Nest backend is listening. And this is a great dynamic configuration that we can then swap out depending on where our app is hosted. So now our API chat endpoint here will be proxied off correctly. And we have everything we need to start actually filling out the component with JSX. Let's go ahead and do this next. All right, so let's go ahead and now start creating our JSX for this component. I'm going to go ahead and start by wrapping everything in a root div. And let's apply some Tailwind styling to use Flexbox. And we'll use flex column height screen to center everything on the screen. And we'll set max width 3XL, MX auto, and padding 4. Now you can feel free to use whatever styles you want for this app. I'm going to create a basic looking chat screen that will suit our needs. So at the top of this chat, I'll have another div, and this is going to contain the input to control which model we've selected and are sending to the backend. So I'll add a class name of margin bottom 4 to this div. And then we can add a label element, which will be HTML4 model input. And we'll have the text called model to let the user know this is the model input. We'll also add some styling to it where we set block, text small, font medium, text gray 400, and margin bottom 2. So in addition to label, we'll have the input itself underneath. And let's go ahead and configure this. We'll set the ID to model input so the label is assigned. We'll set the type to a text input, and the value will be our input that we're controlling with use state, as well as the onChange listener. We want to pull off of the event parameter and then call set selected model and pass in the event target.value, which will set our state with the updated text input value. And then finally, I'll add some styling with Tailwind. So I'll set a number of classes on this input. Go ahead and copy these down as well if you want the same styling. Now, additionally, make sure we've set on this component at the very top that we're marking it as a Next.js client component, because we need to render this on the client side, not on the server, since we're using React state and responding to DOM events. In this case, our form input changes. So we want this to be a client component, so add this to the top of the file so Next.js will render it on the client. Now if we go back to our application at localhost 3000, we can see our model input at the top here, just as we'd expect. All right, so now that we have the input for our model selection, we can now go ahead and actually add JSX that will render out our messages from the use chat hook. And in this case, that's going to be the array of messages in the conversation that we received back from the server after establishing this request to the chat endpoint and opening a stream up as we send additional messages, and we get a response back on the stream from the chat endpoint. This messages property will be populated with the latest messages from the AI model. This will also include any messages that we've sent in the conversation by calling send message. And so we simply need to iterate over these messages and display them inside of our chat component. So let's go ahead and do this next outside of our div for the model input. So for this, I'll wrap everything in a new div, and let's assign a class name to it of flex1 overflow y auto margin bottom 4 and space y4. So these Tailwind styles will allow us to have a scrollable list container where we can render the messages. And so the first thing I want to do is open a JSX expression and check to see if the message's length is equal to 0, meaning we don't have any messages in the conversation yet. Then let's render out a div with some text telling the user that they can start a conversation by typing a message below. I'll give this a class name of text center and text gray 400, as well as margin top of 8. And so with this in place, we should see the text to the user letting them know that they need to start the conversation. So this looks good. And so otherwise, we want to go ahead and now render out the messages in the messages array. So to do this, we'll open up another expression and call messages.map, pull off the message parameter. And now let's go ahead and render an individual message based off of the UI message type that the AI SDK offers us. So we'll go ahead and wrap this in a root div, and we'll assign an ID to this because we're iterating over a list. So each message will have an auto-generated ID on it assigned by AI SDK. So this will be unique, and we can use this to identify the list element. We can also see the other properties that each message has, including the role, parts, and metadata. So on this div container for the message, we'll add class name for styling. We want to set this to a template literal because we want to use Flexbox styling, and then we want to assign the justify content style based on whether or not this message is from the AI model or it is a user message that the user submitted. We want that message to be on the right side of the screen, as we would see in a messaging app, and the AI model messages should be on the left side so we can distinguish between them. To do this, we can open up an expression in the template literal and check on the message. We have the role property. And so this will be equal to user if it is a user message. And in this case, we want to use justify end class to justify it to the end of the container. Otherwise, it is an assistant message, and we want to use justify start to move it to the start of the container. And so this will position our messages where we want, depending if they are a user or AI model message. So now inside of this div, I want to open up another one because I want another class name. And this will additionally be a dynamic class name using a template literal. So in this one, let's go ahead and assign max width to be 80% of the container. And so we can do this with this Tailwind syntax with 80% in brackets. Rounded large property to set a border on it. Give it some padding as well. And then we'll open up an expression where again, we'll check to see if the message role is a user message. Then we want to go ahead and apply a different background to it. So in this case, we'll use background blue of 600. Otherwise, we'll use background gray of 800 for the AI model. And we also want to assign different text style. So for the user, this should be text white. And for the assistant, this should be text gray 100. Now inside of this div, let's go ahead and open up another one for containing the message role text. So for this, we'll have a class name of text extra small, font semi-bold, margin bottom 1, and opacity of 70%. And here we'll check if the message role is user. Then we want to output the text U to let them know this is the user's message, or we'll output the text assistant to let it know that it's the model message. So now we should be rendering out each message with the correct styling and the actual label as to who owns the message. Let's finally go ahead and output the message text. To do this, we'll output another div and set class name to space y3 to get some vertical spacing. And now we want to iterate over the message.parts property. And this is going to be an array of message parts. And so if we look on this property, we can see some additional information stating that this can be system messages and they should be avoided. That's the prompting that we could do on the back end with this conversation. We also have the user messages, which can contain text and file parts. And finally, assistant messages can have text, reasoning, tool invocation, and more. And we're going to go ahead and dive deeper into tool invocation later. For now, we simply want to go ahead and map over the parts array, get access to the part and index we're currently at. And in here, we're going to check to see if the part.type. So this is going to be the type of message, and we can see all of the different types here as we just read. So these are the various types that we can handle. In our case, we just want to check to see if this is a text part, meaning a text response or message from our user. Then we want to go ahead and render out the simple text. So we'll go ahead and return a div where we set the key to the current index that we're iterating over. Let's set class name to whitespace pre-wrap so we have correct wrapping of the text. And finally, simply render out the part.text. So this will output the actual message content for the assistant or user message. Otherwise, we can just go ahead and return null from this map if the part type is unrecognized. And so now at this point, we should correctly be formatting the message and actually outputting its contents, which is great. The last thing we're going to do is output some loading indicators using the status property. And then of course, set up the text input where the user can actually submit their message to. Let's do this next. All right, so outside of our messages rendering, we'll now output another expression and check to see if the status variable, and here we can see all of the values that status can be set to. So this is a loading indicator that can tell us the status of our stream that we have open to the backend. So we have statuses like error, if any errors have occurred, ready, streaming, and submitted. So in our case, I want to check to see if the status is not equal to ready, meaning that we're currently streaming data to the model and waiting for a response back. Then we'll go ahead and render out a dedicated loading indicator. And so for this loading indicator, we're going to use a 3 bubble chat animation. So we'll wrap this inside of a div and give it flex styling. We'll then add another div with class name of background, gray 800, text gray 100, rounded large, and give it some padding. And so now inside of here, we'll have a containing div with flex item center space x2. And now the actual loading indicator will just be an empty div where we're going to set class name on it of width height 2, background gray 400, rounded full, and then give it an animate bounce class, which will add the animation of bouncing to it. We also want to override the style with an animation delay of 0 milliseconds for this first bubble. And then we're simply going to copy this animation div 3 more times. So we have 3 of them, and then increase the animation delay between them. So it looks like we have 3 bouncing bubbles in sort of a loading message indicator. So I'll set 150 milliseconds on the second, and the third will be 300 milliseconds, so the jumping is not synchronized. And now we should have a nice loading indicator for the message processing. Lastly, let's now go ahead and add a root HTML form element where we're going to put our text input for submitting new messages. Now on the form, we can add the onSubmit handler directly in here, pull off the event, and the first thing we'll do is make sure we call prevent default on the event to make sure we don't reload the page. Then we'll check to see if our input.trim, which is the React state we're keeping track of and will set in this text input in the form. So if this value is defined, then we want to call send message, which is the function that UseChat exposes to allow us to add new messages onto the conversation and push that request back to the server. So send message takes in an object where we can specify the text property, and we'll pass in the input from the current text input state, and make sure we then reset the text input by setting it to empty string. I'll also add a class name on the form of flex and gap2. And now inside of the form, let's add our HTML input of type text. We know the value is going to be equal to the input text we're tracking. And on change, we'll reset this. So we'll call set input and pass the eTarget.value to make sure we are recording the latest changes to the text input. We'll set a placeholder of type your message. Let's go ahead and add classes to this text input as well. All right, so I've gone ahead and added some styles to this text input. Now beneath the input, we can also add an HTML button component, which will submit the form for us. I'll have the send text inside. Make sure we set the type of the button to submit so it triggers our form submit handler. And we can also set disabled on it to, well, if status does not equal ready or input.trim is equal to a nullish value, meaning we don't have any text in the input, then we should disable the button. And lastly, I'll add some class styling to this button. All right, so here are all of the Tailwind styles I've added to the button. And so now with this in place, our component should be fully ready to display all of our messages in the current conversation and be able to send new messages using our use chat hook with the default chat transport that we have configured. Let's go ahead and test it out next. Now, quick typo here, make sure the input value that we're assigning to the model is set to selected model and not value, which is the value text of the chat we're sending. So now back in the browser, we can see we have the model text, the chatbot prompt, and the actual text input here to send new messages to our bot. So this is looking great. Let's go ahead and now copy a model from the Vercel AI Gateway. So I'll go ahead and copy the Google Gemini 2.5 Flash and head back to our application, paste in the model we want to send, and now I'll go ahead and try submitting a message in our conversation and send it. Now you can see that our message that we sent has been outlined here on the side we expect with the correct label for it to mark it as our message, the message text, correct styling, and then we can see the response coming back from the AI model. Hello there, how can I help you today? So this is awesome. We can see our chat working in real time. Of course, if we open up the network tab and try sending another request, you can ask it why is the sky blue, for example. We can see we actually make this request, this chat request in the network tab to our API chat endpoint with the expected payload here. So this is going to be what the use chat hook is actually sending to our server with the selected model coming from our custom body. And then the messages array, which is the array of UI messages that our backend endpoint expects, including all of the parts of the message. And so in the latest request we sent, we can see our entire conversation. The most recent part, for example, is type text with our question. And then we can see on the response, which is a stream that gets sent back, is the actual response and all of its parts coming back from the model. So we can see a more detailed view of the entire response. Now, lastly, one issue I want to point out with our chat right now is if we send another message, for example, we have our loading indicator, which looks good, but notice that the message doesn't actually start rendering until it's fully complete, which doesn't really use our streaming functionality as we'd expect. We should see the text streamed as soon as we receive it instead of waiting for the final message. Now, the reason why we're actually experiencing this is because of our NestJS proxying of this API chat endpoint. Now, because this proxying happens on the NestJS server side thanks to our rewrite here, this is causing the stream to not work as we fully expect. So we're going to want to avoid using a NestJS rewrite in this case. Instead, we should change the API endpoint property to now point to a literal value. We can inject this from process env next public API URL, which is how we read environment variables on the Next client side, and still access our /chat endpoint. But now we'll go ahead to our next.m file, make sure we set the public API URL to the same endpoint of localhost 3001. However, we still need to make sure we don't experience CORS errors because we're making a request to a cross-domain resource. Well, we can actually set this up in our NestJS server side by heading back to our main TS where we bootstrap the project and make sure we call app.enableCORS to enable cross-origin resource sharing on the origin we now specify. So we can use app.get, pull off the config service, and read in the UI URL, for example here, To read in the origin, we'll use for our URL. Also set credentials to true. And now if we set the environment variable of UI URL to HTTP, localhost 3000, where the next UI is running, this should allow for cross-origin resource sharing and mean we can make a direct request to our NestJS backend, which should have this streaming functionality work as expected. Make sure we also restart the development server to read in the latest environment variable. So both apps are running. Now if we go ahead and refresh the page and ask it again, why is the sky blue? We should expect to see, as soon as we get data back, we are streaming it immediately to the chat. And this is exactly what we want, the benefit of this streaming-based approach from AI SDK. And this is awesome. It means we get data back sooner and we don't have to wait for the actual full response to be built and sent back. So if we say explain further, for example, we have the loading indicator. And then while this is loading, we are rendering the latest response on the stream to the user so they can get access to the information and don't have to wait. So this is a really good user experience and works very well for chat-based applications. Now, a few more things we want to clean up is on the homepage component. Let's scroll down to where we're rendering out our form. And let's go ahead and make sure we enter in a closing div here before the form starts, and then go ahead and remove one after the form. So this is going to make sure that the form is in still side of our flex box and the input will stick to the bottom of the screen, which is the style here that I would prefer. Now, one more issue we have is if we go ahead and start with our chatbot and ask it, what model are you? We'll see its response is that it is trained by Google. This is what we'd expect. But what happens if we go ahead and try to change our model to example, the OpenAI GPT-5, for example? So if I go back and swap my model out now and then ask it the same question, we'll notice we actually get the same response. So this is unexpected. And if we look at the chat we're sending, the first chat request, the model here is Google Gemini, which is what we'd expect. But then the second request is also Gemini. And so this is an issue. Our updates to the model aren't actually being reflected in the body that we're sending to the server. Now, the reason why we're experiencing this is because right now we're passing the model in a fixed object that doesn't change when we update the state for selected model. Now, in order to fix this, what we're going to do is two things. Firstly, we're going to store the selected model in a React reference. So we'll use ref here from React, pass in our selected model state, and then we'll set the selected model ref dot current value equal to the selected model of the state value. So the state value that changes will update the reference. And now to pass this dynamically, we can actually change out the body parameter to be a function that returns an object each time. And so this is going to use our now selected model ref dot current value. And this is going to cause this value to change every time that our state actually updates. And make sure we're not wrapping anything in use memo here. This is just another implementation that I tried earlier. So we should just have the original transport option and body updated with our selected model ref. And so now with just this change, if we now go back to our application, let's refresh it. Let's go ahead and try the same exercise. So we'll ask it, what model are you? We get back the Google model. And now let's copy a different model, paste it. And let's ask the same question, what model are you? Now we get back a totally different response. Well, we've actually sort of tricked the AI now. It's confused because we're passing it the whole conversation. And previously it answered it's by Google, but now we've changed the model. We can see it's coming from OpenAI. So this is exactly what we'd expect to see. And in the request itself, of course, the model looks correct. So this is great. We now have a fully working chatbot end-to-end using Vercel OpenAI SDK with the ability to change our model through the gateway at any point. And this is a really great scalable way to add AI into any of your applications because we only need a single point to configure the Vercel AI Gateway, one API key to manage, and we have access to all of these great models. And as we know, the models and the rankings of them, the ones that are the best to use for your use case, always changes throughout time. And so in this way, we can keep our code insulated from all of these changes in the AI model. Our code stays the same. All that changes is our model selection, which is a simple string. So this is really cool and fun to use. Now, next up, I want to take this even further and show you how we can actually integrate more of our application's business logic into this actual AI integration by using tools. And so tools are discrete tasks and are essentially any operation like mathematics or interacting with the outside world through network requests or using data from our database, for example, in our application. So tools, you can essentially think of them as actions that a chosen LLM can invoke. The results of these actions can be reported back to the LLM and be considered in the next response. So in the example that we're going to implement, we're going to be able to provide our AI model with a weather fetching tool, which is going to let our AI model call this function, and in that function we'll be able to do whatever we want. In this case, fetch weather data, return that back to the model, and then it can use that data in the response back to its user. And so this is a really powerful pattern because it's essentially how we can provide context to our application that we're building and give that context and data to the AI model for it to use in its response. All right, so let's see how easy it is to integrate tools into our AI SDK chat application. So let's go ahead and see how we can do this. In the chat directory, I'll create a new service called the tools service.ts. So this will encapsulate all of the tools that we'll be providing to our AI model. And just like everything in the AI SDK, this is going to be model agnostic, right? So the tools won't change as we swap models. It's going to be the same input and output. It's just going to be the response coming back from the tool output that will change if you change your model. And we'll see this as we build this out. So let's start by marking our injectable class and export tools service. And so in here, we could provide a different function for every tool that we want to provide in our application. I'm going to go ahead and create a common example that is well documented, a weather fetching tool. So in this example, you can imagine we have some sort of external SDK or network request we'll make to fetch latest weather data from some sort of service or database. And we want to let our users be able to query this through our chatbot. And even better, we can pass the return data back to the model and actually have it process that data. And so the way we do this is simply return the tool function from AI, which will take in a configuration object where we define the tool. All right, so the properties that tool configuration will take will be the same for every tool. The first will be a description for the tool. Now you can see here, this will be an optional description of what the tool does, and it will actually be used by the AI language model to decide whether or not to use the tool. We're giving a hint to the AI that we should invoke this tool when a user message indicates that we should use it. So for example, for this weather tool, well, it will be invoked when we tell the language model what is the weather, for example. It's able to translate that request into the invocation of this tool, which is really cool. So for our example, we'll say description, get the current weather for a location. And then we define the input schema using Zod. So we need to install Zod, the schema validation library we all know and love. Let's go ahead and do this in CD into apps backend. Make sure we install Zod. And the reason why we're installing Zod is so that we can define an input schema for any arguments that this tool will take from the user. So in this case, we can define it with Zod dot, and we'll use the object now since this will be an object. And then we define any properties that can be passed into the tool execution that will pull from the user. And so the LLM will be smart enough to know to ask the user for this input if it is needed further, if it's not an optional. So in our example, we'll specify that the location is a property, a string property that we'll extract. And we can also describe this to give the LLM more context on how it's going to prompt the user, for example, and use this input. So we'll say the city name, and you can add any more input that your tool would need to execute. So the last function we need is simply the execute parameter, and this is going to be the function that will execute the tool. And so in here, we get access to any of the parameters that we defined in the input schema above. So in this case, we can destructure the location property since we defined it, and the LLM will be responsible for passing it in after it prompts the user. And so now at this point in execute, we can return whatever data we want from this tool that will get passed back to the model, and the model can use that to display it back to the user or process the response further and answer the user's query. So in this case, at this point, we would typically reach out to some third-party weather service, get the weather data we need, and return that back. In our case, let's just use some static hard-coded data here. So I'll have an array of temperature data that we'll say we'll sample and can use in this example. And we'll have an array of conditions for the weather. So we'll have different weather conditions that I'll fill in here. And finally, we'll go ahead and return a response object as the result of the execution. And so I'll include the location. For the temperature, we can go ahead and access the temperatures array, use math.floor, and call math.random times the temps.length. And this will give us a random temperature from our array. And we'll go ahead and do the same thing with condition now. Just make sure we access the conditions array and multiply by the conditions length. So now we have a random temperature, a random condition, and let's just say, for example, we can have a humidity property, and we'll just floor math random times 40. And we'll just add 40 to this to make it more realistic. And so now we have this response object, and as I said, this gets passed back to the LLM so it can process the response, do further processing if it needs, or return it straight back to the user. And so I'll also add a get all tools function to the service. And this is what we're going to be returning directly to the model, which is a list of tools that it can invoke during its conversation. So we'll pass the get weather tool as the get weather tool here. So now we have the tool service ready to use. Let's head back into the chat module. Make sure we wire it up into our providers array and head back into the chat service where we now want to inject it into our constructor. And so now we have access to the tool service. We're simply going to go back into our stream text function, and now we can see we have this tools property that we can provide to stream text directly. And so we'll now call our tools service.getAllTools, and that will feed it the weather tool that we configured. And so now the model will be aware of this tool, any tools we define inside of this configuration object. It can invoke any of them and let the user use it or process the result of it further. So this is really all we need to set up a tool in our integration. Let's head back to our chatbot and give it a try. So now back in our chatbot, if I go ahead and ask it, what can you do? It actually is smart enough to know that we've configured tools for it, and it can fetch weather for a location. And so I can say, get the weather for New York City. It's going to go ahead and actually invoke the tool that we've defined for our backend. And you'll notice we aren't actually displaying the response. Now, the reason for this is because, well, remember, from the tool service, we're actually returning this object from the tool response directly. And we need a way to actually parse that tool response on the UI and display it to the user in a given way. Now, in the Vercel AI SDK, this is going to be known as generative UIs. Essentially, we can build out a template UI that receives data from our tools and displays it to the user in a certain format. And so let's go ahead and see how we can do this by heading back into our chat component. All right, so to build this generative UI from our tool responses, we're going to go down to where we're displaying the message. Now, remember, as we saw earlier, our message parts actually have a type associated with them. So by default, we're only rendering out the type if it is equal to text. But now we have a new type we need to account for. We can check here. It's going to be the name of our tool. And so we can actually see this in action. Let's go ahead and simply log out our messages right now. And if we head back to the UI and look at our array of messages, take a look at the latest assistant message here and the parts. We actually have the latest response and we can see the type of it. It is the name of our tool prefixed by tool. So we have tool-getWeather. That's the name of the tool that we provided in our tool service. And importantly, we can see the response from the tool that we are returning from our execute function here in the output object. And so now let's use this to build a generative UI and build a nice little weather widget. So let's go ahead and create a nice little weather widget we can use to display our weather data. So in our web directory, I'll just create a components folder. And let's create a weathercard.tsx component. And we'll go ahead and define our weather card props that we get passed in here. This will be the data of type weather data. And I'll have another interface with our weather data properties. So we know these are all the properties we're returning from the backend. Now in a production app, I would probably keep these in a common turbo repo package, but for now, let's just output these as we know so we can have a type safe component. We'll have all of the properties that we return from the weather tool here. So now we have the props, the data. Let's export function weather card that will get passed in the weather data prop. And let's go ahead and now define our JSX for this component. All right, so just to save a bit of time, I've gone ahead and filled out this weather card component. And here I created a simple get weather icon helper function that takes in a weather condition. And I'm just returning a little emoji for each one just to have some nice effects. You can return whatever you want. And then down below in the JSX, I'm outputting a few divs to output each of our data points. So we have the data location, the icon here based on the condition, the temperature, condition, and humidity. I've titled each one and added some basic tailwind styling. So feel free to copy this directly from the repository or style it however you would like. And with this in place, we can now go back to our chat component. And let's scroll down to where we're rendering out our message parts. So above the return null, we'll check to see if part.type is equal to tool-getWeather, which is the name of our weather tool. Then we're going to go ahead and return our weather card component. So go ahead and import this. We'll pass in a key as to the current index. And then the data is simply going to be the part.output property. Now I'm also going to cast this as type any so that it is a type safe and our compiler doesn't complain about it. And so now with this in place, if we head back to the UI, you can see our generative UI for our weather tool output. And so this is really cool. Now, importantly, make sure that our messages map at the top here, this div also has a key where we set the key value equal to the message ID to avoid any duplicate key errors. Make sure in here we also have part.state equal to output available, which is going to mean that we actually have output data available to render in our generative UI. So now at this case, if we head back to the chat and ask it, what is the weather? Asking us where the location is. So this is good. It means our input schema for the tool is working properly. So let's say we can respond with New York City. And now we can see this really nice generative UI where we're rendering out the weather data based off of the output response we got back from the tool. So this is really cool to see. And we can say, for example, what about in Houston? And it will choose a separate random output value from our tool. And now we're rendering this weather out. So this is really cool to see working as intended. Now, one side effect of adding this tool is if we ask it another question like, why is the sky blue? You can see that the chatbot automatically responds that it can't answer this question. Its capabilities are limiting to providing weather information. Now, this is the default behavior in our AI interaction, where if we define tools without any system prompt, it's going to be restricted to the tools that we provide. So we don't have the rest of the natural language capabilities we had before. To fix this, we can simply add a system prompt to our chat. So a system prompt is essentially a set of instructions that we provide at the beginning of each conversation to instruct the model on how to operate. Now, to add a system prompt to our conversation, all we have to do is update our model messages. We'll still include all of our conversation, but before this, we'll add our own system prompt. And to do this, we simply have to set the role to system on the message, and then we set the content property equal to our system prompt. So here I'll create another function called get system prompt, for example, and this is going to be the instructions on how the model should work essentially, and we can configure this however our application would want. If we want to restrict our app to only using the tools we define, we can tell it to do here. We can provide any instructions to the AI model at this point. So in our case, let's keep it simple. We'll have a get system prompt and return a simple string and say you are a generic chatbot that can answer any questions, but also use the tools that we define to answer the user. So let's go ahead and try asking in a new conversation, why is the sky blue, for example, and you can see we now get back a response from the AI model because we have that system prompt telling it that it can do essentially whatever. And we still have the tool capabilities. So what is the weather in Boston, for example? I get the weather result back. I can also ask what is a calorie, something totally unrelated, and we get the response back. So this is a really powerful SDK, this AI SDK, and I think it has a lot of promise in terms of being able to add and enhance functionality to the apps we write. By using these tools, we can hook it into the business logic, the data, the services that our apps use, and give our users a lot of value by letting them query it in a natural language model. I want to let you know you can get access to the full, almost 3-hour version of this lecture where we take this example even further and add message persistence with our NestJS backend and hook it up to a Postgres database with Drizzle ORM so that we can actually persist our chats after we've completed them. So here we can load our chat history from the database, and I'll show you how we can serialize and deserialize these messages and chat data with ease using the Vercel AI SDK and Drizzle ORM. So again, if you want to get access to that, I'll leave a link below where you can check out my developer website and get access to this full almost 3-hour lecture and get access to all my best-selling Udemy courses and exclusive developer content.